Hello friends, welcome to my channel. In this video I will cover Otto cycle. Already I explained Carnot cycle. Otto cycle in this video I will explain. In Otto cycle it consists of two constant volume process and two reversible adiabatic process. Here 3 to 4 and 1 to 2 both are reversible adiabatic process. PV to the power gamma equal to constant. Here also PV to the power gamma equal to constant. Here constant volume heat addition, constant volume heat rejection, Q2. Here this is 2 to 3 volume is constant, 4 to 1 volume is constant. Constant volume heat addition 2 to 3, 4 to 1 constant volume heat rejection. Then heat supplied process 3 to 4 isentropic process, it's Q1. Here constant volume heat addition 2 to 3 it's heat addition and 4 to 1 heat rejection. So Q1 in 2 to 3 process or Q2 to 3 Cv dt T3 minus T2. Then heat rejection or heat rejected in process 4 to 1 Q41, it's minus Cv T1 minus T4, or we can write it as Cv T4 minus T1. So net work done same like Carnot cycle, it's heat supplied minus heat rejection or Q1 minus Q2. Cv T3 minus T2 minus Cv into T4 minus T1. Then efficiency, thermal efficiency, it's net work done divided by heat supplied. Heat supplied is Q1, constant volume heat addition. So many times this one also asked. Constant volume heat addition and constant volume heat rejection. So here net work done divided by heat supplied. Cv T3 minus T2 minus Cv into T4 minus T1 divided by heat supplied. It's Cv T3 minus T2. So thermal efficiency equal to, here these two terms 1 minus Cv also cancel, T4 minus T1 divided by T3 minus T2. So we can write it as 1 minus T1 will take common, T4 by T1 minus 1 divided by T2 will take common, T3 by T2 minus 1. This is efficiency. Equation 1. And from process 1 to 2 isentropic process, T2 by T1 equal to V1 by V2 whole to the power gamma minus 1. And from process 3 to 4 isentropic process or reversible adiabatic process, T3 by T4 is equal to V4 by V3 divided by whole to the power gamma minus 1. So from here RC, this is compression ratio, RC equal to V1 by V2, V1 equal to V4, V1 by V2, V2 equal to V3, and up to V1 it's Vc plus Vs. Vc is clearance volume and Vs is stroke volume, and V2 equal to V3, it's Vc or clearance volume. We can write it as V1 by V2, we can write it as V4 by V3 or V maximum divided by V minimum. So here already we discussed. So here in this term V1 by V2 we will replace V1 by V2 equal to V4 by V3 whole to the power gamma minus 1. Then this equation will apply in efficiency equation. So from these two equations, T2 by T1 equal to T3 by T4, or we can write it as T4 by T1 equal to T3 by T2. So from here we can cut these two, T4 by T1 minus 1, T3 by T2 minus 1. So efficiency will get 1 minus T1 by T2, or we can write it as 1 minus 1 by T2 by T1. From process 1 and 2, we can write it as T2 by T1 equal to V1 by V2 whole to the power gamma minus 1, and V1 by V2 we already explained, V1 by V2 equal to V4 by V3. So you just replace V1 by V2 with V4 by V3, and V4 by V3 or V1 by V2 equal to RC or compression ratio. So RC to the power gamma minus 1 you will get T1 by T2 equal to. Like this, T3 by T4 you can write it as, in process 3 and 4 you can write it as V4 by V3 whole to the power gamma minus 1, and V4 by V3 already explained, it's V1 by V2 whole to the power gamma minus 1 or RC or compression ratio whole to the power gamma minus 1. So finally T2 by T1 equal to T3 by T4 equal to RC or compression ratio to the power gamma minus 1, or T4 by T1 equal to T3 by T2 compression ratio to the power gamma minus. Finally, in efficiency term, we will apply here in this efficiency term from these two equations, this equation and this equation, we will get 1 minus 1 by RC to the power gamma minus 1. This is Otto cycle efficiency, final exponents. And the efficiency of Otto cycle, it depends on compression ratio and gamma. Efficiency versus RC, if you plot the graph, it will come like this. Here 8 to 11, this region is the best region, and due to knocking we are keeping it as 8 to 9 compression ratio for petrol cycle or Otto cycle, where compression ratio should be 8 to in between 8 to 11. If compression ratio increases, then efficiency also increases. From this graph also you can write, if RC is increases, then efficiency is increases. But due to knocking, we are keeping it in between 8 to 11 compression rate. And for efficiency versus and for adiabatic index gamma, your efficiency also depends on value of gamma. If gamma value increases, your efficiency also increases. Your efficiency, your compression ratio, your gamma. If gamma increases, then your efficiency also increases. This is RC. And finally, efficiency increases with increase of gamma and with increase of RC. In objective question also they are asking this type of question. If gamma value increases, what happened to the efficiency of Otto cycle? Otto cycle efficiency increases. Same for compression ratio also. And this is also they are asking sometimes actual value of Otto cycle or petrol cycle efficiency, SI engine, spark ignition engine, it should be, it's in between 25% to 30%. This is the actual value of spark ignition engine. This graph also very important for objective point of view. Sometimes they will give PV diagram and in 4 options they will give the TS diagram. You have to choose the correct option from the TS diagram. So both PV and TS diagram you have to remember. And it's constant volume heat addition and constant volume heat rejection, and two constant volume process, reversible constant volume process and two reversible adiabatic process. That thing also you have to remember. Thank you friends. Thank you for watching my video. Thank you.